Assalamualaikum. Okay, so next we will go to the next subtopic, which is 5.2, energy and conservation of energy. Okay, so for this subtopic we have two learning outcomes. Okay, and the first one, okay, your first learning outcome is state the principle of conservation of energy. So remember, when your learning outcome is state, you have to remember it in words. Okay, so for conservation of energy in an isolated system, again, okay, isolated system means no external force. Okay, no external force. Okay, isolated system, there is no external force from outside. The total amount of energy is always constant. Okay, so when we have a system and we don't have external force from the outside, the amount of energy is always constant. Okay, so sistem kita boleh jadi apa-apa sahajalah. Maybe kita bola yang kita jatuhkan, that is also considered a system. So kalau kita tak memberi apa-apa external force, amount of energy dia adalah constant. So bila amount of energy dia adalah constant, maksudnya sum of energy initial equals to sum of energy final. Okay, the total initial energy is equal to the total final energy. Okay, maksudnya tak ada energy loss. There is no energy loss, and all the energy in the initial is transferred from one form to another. Okay, there is no energy loss. So we have to remember energy. Okay, energy can be transferred from one form to another. That means from kinetic energy to potential energy, for instance. Okay, daripada kinetic energy kita transformkan dia kepada potential energy, ataupun daripada potential energy kita transform dia kepada elastic potential energy. So energy tu boleh ditransfer. Okay, energy tu boleh pergi daripada satu form yang lain kepada satu form yang lain. Tetapi energy cannot be created or destroyed. Tak boleh energy itu tiba-tiba hilang. Okay, energy tu tak boleh tiba-tiba hilang ataupun tiba-tiba muncul. No, it cannot. Okay, so the energy is constant. So the total kinetic energy, the total energy in the initial will equal to the total final energy. Okay, so what is energy? Okay, we keep talking about energy. What is energy? Energy is the ability to do work. Okay, energy is the ability to do work. Okay, so if we have a lot of energy, that means we can do a lot of work. Okay, so energy is keupayaan kita membuat kerja. So energy tu perlu, barulah work can be done. Okay, so energy is the ability to do work, and the principle of conservation of energy states that in an isolated system, that means a closed system or no external force, the total amount of energy is always constant. Maksudnya the total initial energy is equals to the total final energy. So energy can be transformed from one form to another, from kinetic kepada potential. Okay, tetapi energy tak boleh tiba-tiba hilang, tak boleh tiba-tiba musnah. Okay, so this is the conservation of energy. Okay, so next you have learned this, but I want to just remind you again the types of energy. Okay, so for your syllabus we have 3 types of energy that we're going to focus on. So the first one is kinetic energy. Okay, the first one is kinetic energy. Okay, kinetic energy, or we can represent it as KE. Okay, so kinetic energy is present. Okay, kinetic energy is present. Okay, it's present due to motion. Maksudnya bila objek itu bergerak, okay, when the object is in motion, akan wujudnya kinetic energy. Okay, so kinetic energy is present due to motion. So kalau objek itu tidak bergerak, there is no kinetic energy. But when the object is moving, or when the object is in motion, okay, whether when the object is motion or it's moving, then the object will have kinetic energy. Okay, and the equation for kinetic energy is half mv squared. So this is the equation for kinetic energy. So m is the mass, mv is the velocity. Okay, so this is the first energy that you will learn, which is kinetic energy. Okay, the second energy is potential energy. Okay, or the long name is gravitational potential energy. Gravitational potential energy. Okay, and we write it as, we represent it with the letter U. Okay, and gravitational potential energy. Okay, gravitational potential energy is present. Okay, gravitational potential energy tu akan ada bila due to its position. Kalau tadi due to its motion, sekarang due to its position. Maksudnya dekat mana dia berada. So when the object is not on the ground, okay, the object is on a certain position, maksudnya dia ada certain height, okay, dia akan ada gravitational potential energy. Okay, so gravitational potential energy is due to its position. Okay, so bila objek itu berada dekat atas, okay, ataupun dekat atas lah, so dia dekat atas building, so the object would have gravitational potential energy, so due to its position. Tapi the moment the object reach the ground, tak adalah gravitational potential energy, so dia akan transfer, energy tu akan transfer pergi ke benda lain pula. Okay, so that is gravitational potential energy. Okay, and its formula is U equals to mgh. Okay, U equals to mgh, where U is the gravitational potential energy, m is the mass, g is our gravitational acceleration. Okay, we will just put it as 9.81, and h is the height of the object. Okay, setinggi mana, kan kita kata tadi due to its position, so setinggi mana objek itu, so h is the height from the ground. Okay, so gravitational potential energy is due to its position. Okay, so that's the second energy that you have learned, that you have to identify in this chapter. Okay, so for the third one, okay, the third one is elastic potential energy. Okay, elastic potential energy. Okay, elastic potential energy. So our elastic potential energy is present. Okay, elastic potential energy is present due to a spring. Okay, present due to spring. Okay, due to a spring stretching or compressing. So bila kita ada spring and spring to stretch, okay, stretching or compressing, okay, sama ada dia stretch ataupun dia compress, so dia akan ada elastic potential energy. Okay, so elastic potential energy is due to the spring stretching, so maksudnya makin spring to stretch lah, makin panjang, okay, memanjang, ataupun sama ada dia compress, maksudnya spring tu jadi makin pendek. Okay, so when there's change in the spring, whether it's stretching or compressing, dia akan ada elastic potential energy. Okay, and elastic potential energy kita represent dia as US. Kalau tadi U je, yang ini adalah US. Okay, elastic potential energy. And the formula, okay, formula dia adalah US equals to half kx squared. Okay, Ux equals to half kx squared. So US is elastic potential energy, half k. K is the spring constant. Okay, K is the spring constant, and X is the compression. Sebanyak mana dia compress ataupun sebanyak mana dia extend. Okay, so X tu sebenarnya is in meters lah. So how much dia compress ataupun how much dia extend. Sepanjang mana dia extend, sepanjang mana dia compress, sebanyak mana dia compress. So that is X. Okay, that is elastic potential energy. Untuk elastic potential energy, there is another formula. Okay, there's another formula for elastic potential energy, which is F equals to negative kx. So this one is from Hooke's law. Okay, F equals to negative kx. Yang ini daripada Hooke's law. Okay, Hooke's law is a law untuk spring. Okay, so di mana F tu adalah force, okay, and K is the spring constant, and X is the compression. Okay, so this is the three types of energy that you have to learn. Okay, so remember, kinetic energy is due to motion. So bila objek tu bergerak, dia akan ada kinetic energy. Okay, tapi kalau gravitational potential energy due to its position, maksudnya bila dia ada pada certain ketinggian, dia akan ada gravitational potential energy. For elastic potential energy is due to the spring. Sama ada spring kita compress ataupun stretch. So then dia akan ada elastic potential energy. Okay, so that is for the first learning outcome and the forces that you should know. Okay, so we go to the second learning outcome, which is apply principle of conservation of energy. Okay, the next learning outcome tadi awak state je. Now you have to apply. Apply maksudnya awak kena kenal pasti energy itu transform daripada apa kepada apa. Okay, so kita buat satu-satu. Okay, kita buat satu-satu. Alright, so for the first one, okay, for the first one, Miss letak ni sebagai A. Okay, so for the first one, we have an object up here which has potential energy. Okay, disebabkan position dia. Okay, dan tali tu terputus. So, bila tali tu terputus, dia akan jatuh ke bawah. So, maksudnya energy transfer is from potential energy to kinetic energy. Okay, potential energy to kinetic energy. So, cara penulisan dia adalah sum of energy initial equals to sum of energy final. So, wajib tulis yang principle of conservation tadi. Okay, so initial dia ada apa? Initial dia ada potential energy. So, symbol untuk potential energy is U. Okay, and final, bila dia terputus, bila tali itu terputus, dia akan ada kinetic energy. So, kita letak dia sebagai KE. Okay, and then kita boleh buka equation dia menjadi mgh equals to half mv squared. Okay, so this is how you apply. Maksudnya you tahu initially dia ada energy apa dan energy itu transferred kepada apa. So if it's a question, then akan ada nilai lah. You boleh masukkan nilai dan cari apa yang you nak cari. Okay, so this one is for the first case. Okay, case yang pertama, yang ini. Okay, let's go to the second case. Okay, case yang kedua. Case yang kedua, we have a spring gun. Maksudnya yang ini adalah mainan gun. Okay, so what happens is actually, kat dalam gun ini ada spring. Okay, spring tu adalah compress. Okay, spring tu adalah compress. So, bila adik awak tekan, okay, bila dia tekan gun ini kat sini, dan dia akan keluar. So, what happens is, the spring tu daripada compress akan jadi stretch lah. Okay, dia akan jadi stretch dan yang ini akan keluar. So, bila dia keluar, dia akan ada motion. Okay, so dia akan ada transfer of energy. So sama juga sum of energy initial equals to sum of energy final. So initially dia ada spring yang compress. So dia ada elastic potential energy. Okay, lepas tu bila dia tekan butang dekat gun tu dan benda tu terkeluar, when it's in motion, dia akan all the energy will be transferred into kinetic energy. Okay, all the energy will be transferred into kinetic energy. So, for elastic potential energy, formula dia adalah half kx squared. Okay, and kinetic energy is half mv squared. So, samalah kalau yang ini adalah soalan dan dia akan bagi you nilai. So, you boleh masukkan nilai dan cari apa yang patut. Okay, so this one is for the second case untuk B. Okay, so we go to the third case. Third case adalah C. Okay, kita ada pendulum. Okay, so initially pendulum awak dekat sini. Okay, initially dia dekat sini. And bila dia lepaskan, dia akan turun sampai ke sini pula. Okay, dan kita ibaratkan dia akan stop kejap lah. Okay, dia akan stop kejap. So, bila dekat position ni, okay, when it's at this position, so kita ada dua position, dekat A dan dekat B. Okay, so bila dekat position A, this is the original height dia kat sini, so dia akan naik sampai ke sini. So dekat position A, so kita akan buat sum of energy initial equals to sum of energy final, ataupun awak boleh tulis juga sebagai sum of energy dekat A sama dengan sum of energy dekat B. Okay, so dekat A, we know when the pendulum reaches its maximum height, dia akan stop sebentar. Okay, so when it stop, it does not have kinetic energy lah, sebab dia akan stop kejap, baru dia akan turun balik. So dekat A, okay, dekat A, dia akan ada potential energy sebab dia pada satu ketinggian. Okay, so for A, dia akan ada potential energy due to its position. And then bila dia turun balik kepada B, semua energy dia akan convert kepada, sebab dia tengah bergerak, akan convert kepada kinetic energy. Okay, so kita boleh bukakan equation dia menjadi mgh equals to half mv squared. Okay, so dekat point A, pendulum tu akan stop sekejap. So when it stop, it does not have kinetic energy. Dekat maximum height dia akan stop kejap. Lepas tu bila kita lepaskan dia dan dia turun sahaja, dia akan mula ada kinetic energy. Okay, so this is the energy transfer untuk case yang ketiga kita, which is case C. So this is the energy transfer. Okay, kita ke case yang terakhir, which is case D. Okay, the last case. Okay, so for kat sini, okay, this one is quite common untuk exam bagi soalan macam ni. So you have to identify dekat each position dia ada energy apa. Okay, so first, okay, Miss letakkan ni sebagai position A, position B, position C dan seterusnya. Okay, so dekat position A, sebelum kita lepaskan bola itu, okay, sebelum kita lepaskan bola tu, it is not moving. Okay, it is not moving and it is at a certain height. So dekat position A, dia akan ada all potential energy and no kinetic energy. Okay, lepas itu bila dia sampai position B, okay, bila dia sampai position B, dia dah sampai kat ground lah. Tapi dia takkan stop dekat B, dia terus akan bergerak. So at position B sebenarnya dia akan ada kinetic energy. Okay, and then dia akan naik balik pula kepada position C. Dekat position C, dia tak stop juga. Okay, dia tak stop. So ada juga kinetic energy, tapi ada juga potential energy sebab dia masih ada certain height. Tapi height dia tak setinggi lah height pada initial tu. Okay, so some of the energy are in the form of potential energy and some of the energy are in the form of kinetic energy. Okay, lepas tu dia tak stop kan, dia tak stop. So dia masih ada kinetic energy dan dia turun balik. Okay, so bila dia turun balik, dia akan ada kat sini samalah, all kinetic energy and no potential energy. Okay, dan dia naik balik ke atas dan dia tak turun dah. So dia stop ke atas. So bila dia stop dekat atas, all potential energy and no kinetic energy. Okay, so dia akan transfer balik and bila dia dah stop, so semua akan jadi potential energy balik. So dekat setiap point ini, you can see the energy is transferred from one form to another. Okay, energy tu bertukar daripada potential ke kinetic, kinetic ke potential. Lepas tu ada kinetic sikit dan ada potential sikit. So the energy form is changing. Tetapi energy tu is not destroyed ataupun tiba-tiba muncul. No, it is transferred. Okay, so dekat sini you need to remember. Okay, contoh ni Miss letak ini position A, position B, position C, dan yang ini position D, and yang ini position E. So what you need to know is, okay, dekat setiap position, sum of energy dekat A sama dengan sum of energy dekat B. Okay, and total energy dekat C sama dengan total energy dekat D. Total energy dekat D sama dengan total energy dekat E. Okay, so setiap position ini dia ada total energy yang sama. The energy is constant. Okay, cuma energy tu is in a different form. Sama ada dia potential energy ataupun kinetic energy ataupun dia gabungan potential dan kinetic energy. Tetapi total energy dia masih sama. Okay, so this one is the main concept you have to remember. So kita boleh samakan lah. So kita boleh ambil energy dekat A sama dengan energy dekat E. Boleh, sebab pada setiap point total energy dia adalah sama, cuma energy dia is in a different form. Okay, so contoh Miss ambil energy dekat A sama dengan energy dekat, let's say kita ambil B lah. Okay, so energy dekat A kita tahu dia adalah semua potential energy. Okay, dan energy dekat B adalah semua kinetic energy. So kita boleh buka dia yang ini jadi mgh. H tu adalah height yang inilah. Okay, mgh equals to half mv squared. Okay, sekarang untuk elakkan kita confuse, kita letak H ni sebagai H dekat point A dan V ni sebagai V dekat point B. Okay, dan kita boleh masukkan nilai if you have nilai lah dalam soalan nanti. So this one is untuk A dan B. Okay, kita boleh juga buat kita boleh juga buat B and C. Okay, boleh juga kita buat untuk B and C. So contoh untuk B and C, sum of energy dekat B sama dengan sum of energy dekat C. So energy dekat B ada kinetic energy. Okay, dekat B ada kinetic energy. Okay, sebab dia akan bergerak. Tak adalah dia stop dekat B kan, dia akan keep moving. Okay, dan dekat C dia ada gabungan kinetic energy and also potential energy. Kenapa dia ada gabungan? Sebab bila dia naik dekat C, dia akan terus turun balik. Dia tak ada point yang dia stop. So akan always ada kinetic energy dekat situ. Okay, and disebabkan dia ada pada certain position, dia akan ada potential energy juga. Okay, so kita boleh bukakan dia. So dekat sini Miss kata make sure you label. So ini akan jadi half m VB. This is velocity dekat B squared. Yang ni akan jadi sama juga kinetic energy half m. This one akan jadi VC lah, VC squared tambah dengan mg h. Tapi kita tak boleh letak h sahaja sebab ada h dekat A juga. So ini kita letak sebagai HC. Okay, so this one akan jadi energy dekat A sama dengan energy dekat C. Okay, so and so on lah. So awak boleh buat tadi kita dah buat B dengan C, awak boleh buat C dengan E, C dengan D, D dengan E. Awak boleh even buat A dengan C. Okay, so contoh A dengan C akan jadi yang ini sama dengan yang inilah. Boleh juga. Okay, sebab total energy dia dekat setiap point adalah constant. So energy cannot be transferred or destroyed. Sorry, energy cannot be created or destroyed. Energy can only be transferred. So it will be transferred daripada one form to another. And we have three forms of energy: kinetic energy, potential energy, and elastic potential energy. So energy can be transferred but cannot be created or destroyed. Okay, so that's the concept untuk 5.2. So before you watch the next video, so make sure you have tried the example lah sampai example number 8. Okay.